So we've gotten fairly comfortable in dealing with degree measure. And up to this point, we've always talked about degrees the same way we would talk about just any other real number. In other words, we've used base 10. So if we wanted to refer to a fraction of a degree, for example, like 8.2 degrees, we view that as 8 whole degrees and then 2/10 of another degree. So in other words, degrees were divided up, fractions of degrees were divided up in a way that was consistent with base 10. Well, today we're going to look at a different method for dividing up these degrees. And instead of dealing with whole degrees, tenths of a degree, and hundredths of a degree, we'll look at degrees, minutes, and seconds. Now, let's suppose that this rectangle, the area of this rectangle represents a degree. It's just to give you a visual. Now, if we were, in the past, we would have viewed this degree as being divided up into 10 equal parts. Each part, of course, would be a tenth. Well, what we want to do now with this degree is divide it up into 60 equal parts, so that each part is 1/60th of the whole degree. And what we're going to do is call each of those equal parts a minute. So you can see here that 1 degree is the same as 60 minutes. We've just divided it up into 60 equal parts. It's just like if we were dealing with base 10, we would say that 1 degree is the same as 10/10. Okay? So we have, there are 60 minutes in a degree. Now, one step further, what we want to do is we want to take each one of these these minutes and divide those up into 60 equal parts. So I don't know how well you can see that, but each of these little rectangles are divided up into 60 equal parts. So now we have seconds. And notice, for each minute there are 60 seconds. So notice this minute right here is subdivided in here into 60 equal parts. So this is, remember, the whole thing is a degree. We divided it up into 60 equal parts. Those parts were minutes. Then we divided each minute into 60 equal parts. Those parts were seconds. So here, notice, there are 60 seconds in this one rectangle. Now, so here's what we have. 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. And this is the notation that we'll use. A minute will have just 1 mark up here, and the seconds will have 2 marks. So what we have is that 1 degree is equal to 60 minutes, and 60 minutes is equal to 3,600 seconds, which is 60 squared. So it's very similar to base 10. We're just dividing things up a little bit differently. So let's explore this notation a little bit further. Let's suppose that we have this. Okay? Here we have 15 degrees, 30 minutes, and finally 15 seconds. So this is the way we would write things if we're talking about using degrees, minutes, and seconds, and we want to express that we have fractions of degrees. We have 15 whole degrees, and then 30 minutes, and then 15 seconds above that. Okay, so there's a little bit about the notation. Now, let's look at how we would convert from the decimal representation of degrees and fractions to degrees, minutes, and seconds. So let's suppose that we have 13.5 degrees, 13.5 degrees. Now, so here we have base 10. Now notice what this is saying is we have 13 whole degrees and then half of another. Well, half of another degree. Well, that's 5/10 if we've divided the degree up into 10 equal parts. Well, what if we've divided it up into 60 equal parts? Well, that would be 1/2 of 60. So we just multiply 0.5 times 60 and we get 30 minutes. So this could be written as 13.5 degrees is 13 degrees and 30 minutes. So notice what we did. We took the decimal part and just multiplied it by 60. Now let's look at another example. Let's suppose we have 13.12 degrees. Now realize what this says. This says that we have 13 whole degrees, but 12% of 60 minutes. Well, how do we get 12% of 60? Well, just multiply by 0.12, and this gives you the number of minutes. We have 7 whole minutes and 20% of 60 seconds. So now we want to get the 60 seconds. We want to get how many seconds? So I'm going to multiply the 0.2 times 60, and I get 12 seconds. Now let's see what the final result is. 13.12 degrees is 13 degrees, 7 minutes, and 12 seconds. Now remember, we got the 7 minutes from our first computation. In other words, we look at how many whole minutes we have. We leave off the decimal part. Now, the 12 minutes comes from when we took this decimal part and multiplied it by 60. So notice, each time what we're doing is we're taking the decimal part and multiplying it by 60. I take the 0.2, multiply it by 60, and get the 12. Here I multiplied the 0.12 times 60, then the 0.2 times 60, and so forth. So each time you're just multiplying by 60, the decimal part times 60. Now, let's suppose we go the other way and we have degrees, minutes, and seconds, but we want to have a representation in decimal form. So here's what we do. Let's suppose we have 15 degrees, 10 minutes, and 6 seconds. Now, what does that mean, really? Well, that means we, of course, have 15 whole degrees, but we have 10/60ths of another degree. Right? That's what 10 minutes is. It's 10/60ths of a degree. And we have 3,600ths of 1 degree. Because, remember, it's very similar to base 10. We have 6, instead of 10 to the first and 10 squared, like the tens place and the tenths and the hundredths, we have the 60th and the 60th squared. So here's 10 60ths of a degree, and this is 6 60th squared of a degree. Okay. So here's what we have. 15 degrees, 10 minutes, and 6 seconds can be written this way. 15 degrees plus 10/60ths of a degree plus 6 over 3,600th of a degree. And if you work that out, you get 15.1683 bar degrees. So converting from degrees, minutes, and seconds to decimals is very simple. Okay. Now, we'll look at some operations. Let's suppose that we have degrees, minutes, and seconds here, and we're subtracting degrees, minutes, and seconds over here. And we're accustomed to subtracting when just decimals are involved. So we know the process there. We know about the borrowing and all. Well, we're going to use the same ideas here, only we got to remember we're not in base 10. We're dealing with 60ths. We're dealing with degrees that have been divided into 60 equal parts rather than 10. So we have to keep that in mind and use the same principles of borrowing and that sort of thing. So notice we have 30 degrees, 15 minutes, and 4 seconds minus 10 degrees, 11 minutes, and 20 seconds. Now here's the problem. We want to subtract these 20 seconds from these 4 seconds. Well, of course, that's not going to work. We're going to need to borrow because this top number is smaller than the bottom. So what we want to do is come over here to the 15 minutes and recognize this. If I just take one of these minutes and put it over here, That's the same as taking 60 seconds, right? Because 1 minute is 60 seconds. So that's what I'm going to do. I'm going to take 60 seconds from here, which is just 1 minute. And there it goes, 60 seconds. And now notice the 15 has been reduced to 14, and the 4 has been increased to 64. Because I took 60 seconds, which is the same as taking 1 minute, now I can subtract. Notice. 64 minus 20 is 44. 14 minus 11 is 3, and 30 minus 10 is 20. And there we have it. Notice, so it's the same techniques that you learned in elementary school. You're still borrowing, it's just you're not dealing with base 10 numbers. You're not taking 10 ones away from and putting it someplace else. You're dealing with 60s. Okay, now let's look at an addition. Now, let's suppose we want to add these two. So I take 14 degrees, 44 minutes, 50 seconds. I'm adding that to 10 degrees, 32 minutes, and 11 seconds. And if I add those, notice what happens here. First of all, I get 61 seconds. Well, I don't want 61 seconds there. Notice 61 seconds, all that is just 1 minute and 1 second, right? Because 60 seconds is a minute. So what I'll do is I'll rewrite this way. I'll rewrite this. I'll take 60 of these seconds and put it over here with the 76, and now I have 77. And then I just have 1 second here. So I took 60 seconds, which is 1 minute, and added it to the 76 and got 77. Now here's what I have. Now that's still not exactly what we want, because notice that 77 is 1 degree and 17 minutes. So why don't I take that 1 degree and put it over here with the 24 and make it 25, and that would just leave a 77 here. So I have 25 degrees, 17 minutes, and 1 second. So I took 60 of these minutes, which is 1 degree, and that's how the 24 came up to the 25, and that just left us 17.